All right. So again, what we're learning today is relationships within a triangle. So we are dealing with just one triangle and looking at information about that. So far, we've compared separate triangles and decided if they were congruent, separate triangles to decide if they were similar. Now we're looking at just one triangle, what we know about that. All right. So a reminder, as you look at your assignment sheet, we are going to have a quiz next class just over factoring and what we're doing today. Now what we're doing today, half of it you've already seen before, so ideally this quiz should be a good one for you because 2/3 of it is what you did before coming to geometry. But we will recap everything today. So next class we will go over homework questions and then take that quiz. Okay. So make sure you come see me if you have questions before next class. All right. Let's go ahead and take a look at your notes. So again, this is relationships within a triangle. We're looking within one single triangle. Now our first two theorems here kind of go hand in hand. The first theorem says if one side of the triangle is larger than another side of a triangle, and the angle opposite that long side is larger than the angle opposite the other side. Vice versa, if one angle of a triangle is larger than another angle, then the side opposite that first angle is bigger than the side opposite the second angle. Let's talk about this. Alright, so really these go hand in hand. The second theorem is just kind of the converse of the first. In the sense, it's not really converse, but it's flip-flopping the fact that we're starting with the side and looking at the angles. The second one we start off with the angles and look at the sides. So what our theorem here says that if in this triangle ABC, let's just say this is 5, 7, and 10. Alright. So here I've been given the side lengths. Alright, so I'm going to start off with this theorem here. If one side of a triangle is longer than a second side. So let's focus on just two of these sides. Let's go with side 5 and 10. Do you agree that one of them is longer than the other one?
Yes.
Good. Then the angle opposite the first side is larger than the angle opposite the second side. So if I look, 10 is my bigger side. What is the angle opposite of 10? B. But that means that B is going to be my larger angle. 10 is the larger side, angle opposite will be the larger angle. What is the angle opposite of 5? C. So since I know that 10 is bigger than 5, the angle opposite, angle B, will be bigger than the angle opposite of 5, which is angle C. Alright, now we usually write in measures here, but this is just a quick little example. What this theorem says is that if I know something about my side lengths, I can at least know the order of the angles. I don't know the actual measures, but I can know that B is going to be a bigger angle than C. Questions with that?
So if we're doing this theorem, we're going to have to write it out.
We will not be using this theorem in proofs. For this little bit, we won't be using this theorem in proofs. Monica, do you have a question? Okay. So what's cool with this then is that I can go ahead and use this to help me figure out all three sides here. Okay, let me just erase it right. What we say, 5, 7, and 10. Okay. So if I have that side, which side is my biggest again? The side.
AC.
Good. Side AC. So the measure of AC is my biggest. I'm just going to write a little L above to mean largest. What's my medium side?
BC.
Good. BC. I'm just going to write a little M to mean medium. So that way when you look back, you know what we're doing here. And my smallest side then would be AB. Alright, so my large side is AC. We have that measure 10. My medium side is BC. And my small side is AB. So the measure of AC is the biggest. So it's bigger than the medium one, which is bigger than that small one. Do we agree with this statement that we just made?
Yes.
Okay. So if I know the order of my sides, then I can know the order of my angles. Again, it's the angle opposite. So side AC, what was that angle opposite? B. So I have my measure of angle B. Again, I can know that's going to be my largest angle. All right, and then what is my side opposite of BC?
Okay.
A. It's my measure of angle A. I can know that's going to be my medium angle. And then last we have opposite of AB would be angle C. So measure of angle C. And again, that's going to be my smallest angle. So again, if this is my largest side, the angle opposite is my largest angle. If this is my medium side, the angle opposite is my medium angle. And likewise, if this is my smallest side, the angle opposite is my smallest angle. Again, we don't know the actual measures of the angles, but I do know the order of them. Samir?
You know it says that AC is like the biggest one and BC is the medium.
Mm-hmm.
Will the actual picture correlate to, like, could you just like look at it and say, figure out the same?
No, they would have to give you actual angle measures because we can't trust the picture. So actual measures would be given to you. So you'll see, like, for that first example, notice how both pictures all have numbers with it. It would be a problem similar to that. Or they might, instead of drawing the picture, just give you the numbers. Like they might say the measure of AC is 10, the measure of BC is 7, and the measure of AB is 5. But they'd have to give you the measures for them. Come on.
Is it just because there isn't always a pattern where the angle that's the largest will be the angle that's in that line? Like for H.
So like how B is not a part of the same.
Yeah.
Well, that actually will happen every time because if you think about it, the angle opposite would have to be the letter that does not make up the side, right? Very good observation there. So mine was just noticing that this is side AC, so angle B, which makes sense because B would be the angle opposite, which means it can't be a part of that side. Very good observation. All right, so again, we can go the other way. If I know the order of my angles, then I can then know the order of my sides. Okay? So what these two do is it allows you to, I'm just going to write above it. It allows you to order your angles and sides. And what I mean by order is know which one's your largest versus smallest or medium. And we won't always go from largest to smallest. You just have to follow the directions on that, what they're asking for.
How would they give like the measure of our largest, like medium and small of the picture?
They would give you the actual measures of the angle, or they might give you two and you have to find the third one. But yeah, they'd have to give you either the measures of the sides or the measures. Other questions so far? So really not too bad of a topic. Let's go ahead and practice it with a couple problems. So list the angles of the following triangles in order from largest to smallest. Largest to smallest. Make sure you pay attention to the directions, because this is not hard, but people get it wrong because they go in the opposite order. Alright, so my largest to smallest, so let's go ahead and identify our small, medium, and large of the triangle here. So I've got, this is my small side, this is my medium side, and this is my large side. Alright, so if TS is my largest side, what's going to be my largest angle? R. Angle R. Again, that's my largest. And then what is my medium angle going to be? Good. Angle T. And what's my small angle going to be? Angle S. Good. Now, you don't need to write this little LMS. If that helps you to put it in the proper order, by all means, go and do so.
Do you not put the greater sign?
No, it just asks us to list them.
Oh.
Yeah, so I'm just listing them in that order.
And
Yeah, you are more than welcome to write the little LMNS. If that helps you to guarantee you're going in that proper order, by all means do so. What I'm looking for is what's in the box. Alright, I want you guys to go and try that next one.
Do you have to write measure of angle R?
No, because that's a good question. Here we're just listing the angles. So we are just using proper notation where we're saying angle R. It's not asking for the actual measure itself. The reason why we used it before is because I was saying the measure of the angle was the biggest value. So here we're just talking about the angle, so just angle notation. All right, go ahead and try that next one, ordering that. Alright. Again, we're going from largest to smallest. What is my largest angle?
B.
B. Good. Medium angle?
U.
And smallest angle?
W.
Alright, are we good with that? Okay. So now let's take a look at the next couple problems. Name the longest and shortest side of the following individual triangles. Notice the directions have changed. They're not asking us to list them in a particular order. They just want to know what is the longest side and what is the shortest side. Alright, now taking a look at my picture here, I know two of my angles. But it's possible that this third angle could be smaller or bigger than one of those angles there. So how do I find that third angle? Teresa?
So you would add the 9 to the 43, and then you would get 133.
Alright.
And then you would do 180 minus 133 and get 46.
Are we good with that? Questions on that? Now for this particular problem, because it's a right triangle, I could have also just said 90 minus 43 to get that 47. But again, keep in mind all three angles have to be 180. Alright, so I have, now that I have that angle, I want my longest side, and I want my shortest side. Alright, which side is my longest side? FD. Now make sure you use proper notation here. We are talking about the side. It's not asking about the measure. We want to just name the longest side. So when we name that side, we need to use that line on the top. And what is my shortest side going to be? ED. So remember, trust the information, not the picture, because the picture is clearly not drawn straight. Alright, questions with that first one? Okay, go ahead and try the next one. Alright, so for this one, we don't know angle I. When we solved for it, what did we get for angle I? Here, 27. Did we agree with 27?
Yes.
Okay. So what's my longest side? GI. Make sure you have proper notation there. And my shortest side?
HJ. I mean H.
HG or GH, either way. There. And again, make sure you have that little line. Alright, questions with that? Those first two theorems, really not bad. And again, just allows us to know which order of our sides or order of our angles. Alright, so next we have the triangle inequality theorem. Now, you actually dealt with this in elementary school to a certain extent, but we are going to talk about it more. So it says the sum of the lengths, and that should say of, the sum of the lengths of any two sides of a triangle is greater than the length of the third side. Now let's talk about this for a moment. Let's investigate this. Are you with me on that? Don't draw this down. Don't draw this picture. Let's just kind of talk about this. If I have a triangle, let's say side 10, and let's go with 1 and 2. Can that be a triangle?
No. Yes. No.
I want you to try and talk with your counterpart. Decide yes or no, and why.
Yes.
Maybe like that. Like he like
Alright, bring it back up front. Give me thumbs up if yes, it can be a triangle. Thumbs down if no. Alright, who can explain to me why it cannot be a triangle? Come on.
No, because
any two sides need to be greater than the third side when added, and 1 and 2 is smaller than 10 because it equals 3, so you can't have a triangle.
Good. So I try to draw in, it's not to scale, but kind of an example of what's happening here. I have my length of 10, and I have a side of 1 and a side of 2. Can I get those to meet up to actually make a triangle? No, they're not long enough to do so. Even if I try to draw the 2 over here, that's still not going to meet up with the end of that 10, right? So we need for that third.
What if you just convert it? No, Teresa, it can't happen.
So if you think about it, Teresa, so a piece of paper, Teresa,
Yeah.
a piece of paper is 8.5 by 11, right? So this is 11 inches. So let's say this is about an inch, right? And it's about 2 inches. Can I ever get those to meet? No, so it's never going to close that figure to be able to get that triangle. Does that make sense? We can't even get them to touch. Or if I went over here, it'd make this little triangle, but that's not length 11. It can't meet that other side. Alright. So this is why we have to have the 2 sides of the triangle greater than that third side. Alright, so let's take a look at another possibility. What if I had, let's go with 3 and 7. Talk to your shoulder partner, can that make a triangle?
Oh, no.
Yeah, because
It has to be greater.
Alright, show me thumbs up for yes, it's a triangle, down for no. Alright, I'm seeing a lot of no's. Who would like to explain why this one can't be? Lucy?
Okay, so when you have 7 and 3 and then you have your 10, when they start to fold and meet in the middle, they'll just fall down and make a line.
Right, so I'm going to have, let's say, 3 here and 7 here. What Lucy's saying is that when they come to meet, they're just going to be the exact same length as that. They basically don't create a gap, right? Because in order for it to actually make that triangle, I need them to be bigger than 10. I need them to add up to be bigger than 10 so that they actually meet at something above it. Whereas if I were to lay them from the ends, they would just come and fall flat right on top. Does that make sense? Questions with that?
So if it asks why it isn't a triangle, do we have to say that, or can we just say that it doesn't add up to be greater than 3?
You could literally just write 3 plus 7 is not greater than 10, like with the length there. And that's what we'll take a look at. Alright, so what this is saying, it says the sum of the lengths of any 2 sides is greater than, and that's the key piece there, greater than the length of the third side. So let's investigate kind of the 3 scenarios here. Let's just start off with, again, we'll look at it in general with the small, medium, and large side. Alright, so we have a small side, a medium side, and a large side. So the sum of the lengths of any 2 of these sides must be bigger than the third. So my small plus my medium must be bigger than my large. We gotta look at all combinations, right? Alright, let's do small plus large must be bigger than my medium. And last, what would be my last combination? Okay, so medium plus large must be bigger than small. Alright, now let's investigate this going from right back. Medium plus large is greater than small. Do I need to check this, or will this always be true? Talk with your shoulder partner.
Always be true.
Can you wait until we finish this? Good. Alright, what do we need? Is it always true, or do we have to check it? Why? Who would like to explain why it's always true? Cameron?
Because medium is already bigger than small and large side.
Yeah, individually, these by themselves are already bigger than small. So, of course, them added together is going to be bigger than small. So, this is always true. Good. How about this middle one? Always true. Kind of the same idea. Large is always bigger than my medium, so of course anything added to it is always going to be bigger. So this one is also always true. Alright, How about this one? Do I need to check it, or is it always true? Check it. Check it. It's not guaranteed that my small, my medium will be bigger than my large. So this one we do have to check. So what we've just discovered is that there's actually a shortcut. We don't need to check all three situations. I just need to check that my small, my medium add up to be bigger. Questions with that? Alright, so go ahead and try. Once I find my first. Go ahead and try A and B. Is it possible for that triangle to have those sides? Or is it possible to make a triangle? Yes. Good job. I'm proud of you.
It's got to be graded into the list. You got one.
Yeah.
It's a range. Wait, what? No, I think
No, you did it right.
Alright, so again, we're checking that small and medium is bigger than my large. So my small side and my medium side is bigger than my large side. What do we get? Let's say plus 9.
17.
17. Is 17 bigger than 10?
Yes.
Yes. Now I am expecting that you show your work to support that, but this is sufficient there. Alright, so let's check B. I have my small plus my medium. Is this bigger than my large? What's 5 plus 11? Is 16 bigger than 16? No! Okay, so just draw that line through the inequality to indicate it is not. Alright, questions on that? Still not too bad, right? So let's go take a look at our next piece. We're still going to use this theorem to help us in solving for an unknown side. So what they've done here is they give us two lengths of a triangle, and we have to find the range of possible lengths for that third side. Now the problem is, I don't know if that third side is my small, my medium, or my large. So we have to find that possible range. It could be anywhere. We have to decide, is it from 1 to 10? Is it from 2 to 15? What is that range that it could be? Alright. Now, I don't know my third side. I'm going to call it X. And again, I don't know if this is my small, medium, or large. So I need to go back to that theorem that we were just discussing. Any two sides must add up to be bigger than my third side. So 3 plus 5 has to be bigger than X. I also need to have 3 plus X must be bigger than 5. And X plus 5 must be bigger than 3. Are we good with setting up those three scenarios? Questions on that? Yes.
Maybe X plus 5 is bigger than 3 because 5 is already bigger than 3.
Great question. We'll go through it and then we'll see what happens with that. Good job thinking ahead of that. All right, so let's go ahead and solve each of these. So here I get 8 is greater than X. Here, when I subtract 3, I get X is bigger than 2. And here, when I subtract 5, I get X is bigger than negative 2. Now, this is what Sam was just bringing up. Notice, if X is bigger than 2, doesn't that already meet the requirement that X is bigger than negative 2? If X is bigger than 2, then of course it's bigger than negative 2. So we actually don't need to worry about that one. It will not affect your answer because this has already taken care of that restriction. So let me just recap that again. X being greater than 2, if I think about this on a number line, here's 0, here's 2, here's 2. Since X is bigger than 2, it already meets the requirement that it must be bigger than negative 2. So this actually does not impact my answer. Alright, so let's take a look at what we have left to work with. Alright, so I have the restriction X must be less than 8, as well as X must be greater than 2. Well, I can just combine that into one inequality. X is greater than 2 and less than 8. And here's my answer. What type of inequality is this called?
A double inequality.
Yes, but the mathematical term is
That's
starts with a C. Very good, Patty. A compound inequality. Good.
Smart.
All right. So again, x is less than 8, but it is also greater than 2. So that means my third side must fall somewhere within that range. Now, can it equal 2? No, because watch what happens. If it is 2, 3 plus 2 equals that. It's not bigger than that. So that's why it has to be bigger than 2 and it has to be less than 8. All right. Now, let's take a look at a shortcut for this. So again, I don't know if x is my small, medium, or large side. So this range gives me those possible different options that will accommodate for that. If x was my smallest side, so that's what I want to raise this. Well, we kind of already talked about this. If x was my smallest side, we know that it has to be at least 2, right? Because 3 plus 2 gives me 5. Or another way of saying it is 5 minus 3 is 2. So it must at least be bigger than 2. Does that make sense? For it to be the small side, it has to be at least bigger than 2. That's for this guy. Notice that this is just simply the subtraction, the difference of my two known sides. Now notice over here, how do you think 3 and 5 relate to that? Add them. So what we actually have is that third unknown side must fall between the sum and the difference. Smart word, with me? The sum and the difference of those two sides. Now please, when you do your difference, do bigger minus smaller, so we have a positive value here. We talked about how the negative's already taken care of. But that's actually a shortcut for us. Rather than having to check all 3 situations, we know this last one, is going to give me something that's already been overridden. And if we look here, this is just simply 3 plus 5, and here it's 5 minus. Okay, so that is a shortcut for us. So if we take a look at B, I can actually go ahead straight to my answer. That third possible side, we go ahead and subtract these. What's 15 minus 13? 2. And add them. 15 plus 13. 28. And that is my answer. You are welcome to go through this long, drawn-out method. That is the reason why we can do what we just did. Questions with that, Samir?
So, if how we cross out x is greater than minus 2, can you put that in the compound inequality?
So it's already satisfied within here because we have x is greater than -2, but it also has to be greater than 2. This is a tighter restriction, so we go with the smaller restriction because it is more specific to this guy here.
So if you get it wrong.
It would be, I'm not sure how you would put it in there. I guess, I mean, you could say like -2 is less than 2, which is less than x, which is less than 8. But this would be nonsense for us. We wouldn't need that. Does that make sense? Other questions on this? Okay. So let's go ahead. Let's flip it over. The backside should look very familiar to you.
I remember this.
Alright, who remembers how to pronounce this? Pythagorean. Pythagorean theorem. So there was a mathematician called Pythagoras. He was the one that discovered this theorem. So our Pythagorean theorem is true for only one type of triangle. Right triangles. So in a right triangle, the square of the hypotenuse is equal to the sum of the squares of the legs. Let's first talk about parts of a triangle. Which piece is my hypotenuse? The long one. How do I know which one's the long one? Opposite of my right angle. Guess what's always the biggest angle in my triangle? My right angle. 90. Doesn't that just make sense of the theorem we started out with? Biggest angle, biggest side. So this is my hypotenuse. And then these are my legs. Okay. Now, instead of writing out in words the square of the hypotenuse, I'm going to go ahead and So you guys are familiar with like a squared plus b squared equals c squared. So c represents this side. I'm going to call this c. Notice, and this is a common thing that we do in geometry. Notice side c is opposite of angle c. And then we will call this guy side A. Side A is opposite of angle A. And this guy we'll call side B. Okay, so sometimes you'll see pictures drawn where instead of labeling the vertices, they'll label the sides. Alright, so what we have is the square of the hypotenuse, so c squared, is equal to the sum of the squares of the legs. So a squared and b squared. These are my legs. Square them, add them together, and get my hypotenuse. Make sure you identify which one's your hypotenuse before you set this up. So if a squared plus b squared, my two legs, squared, add up to be my hypotenuse squared, we know that it's a right triangle. Notice that a and b are going to be the small and medium side, because again, we talked about hypotenuse is always that largest one. Alright, so for our first one, find the value of x. We can go and set this up. 3 squared plus 7 squared equals x squared. What is 3 squared? 7 squared?
49.
And x squared we don't know yet. 9 and 49? 58. X squared. And now let's go and square root both sides. So x is plus or minus. Can I break down 58? It's an even, right? It's an even number, so we can break it down. Let's start off with 2. 2 times what gives me 50?
29.
Are we going to 29?
Yeah.
Okay, now can I break down 29?
No.
No, so although 58 can be broken down, the radical of 58 cannot, because we don't have any factors or perfect squares. So we have then plus or minus the square root of 58. Now can I have both the positive and negative in this situation? No. X is talking about a length. I can't have a negative length. So my answer is just the positive root 58. Again, because it's just simply x, I cannot have that negative value. Questions with that one? Alright, go ahead and do B real quick for me. Alright, what did we get for x for this one?
Square root of 51.
Square root of 51, do we agree? Again, notice your x is not always your hypotenuse. So make sure you set up your problem first with the proper values. Alright, so let's take a look at C and D. Same process. Just be careful with your setup. What is my hypotenuse in C? Good, so this here is my hypotenuse. Alright, so when we set this up, I have 12 squared plus x squared equals 2x squared. Notice that that entire quantity, 2x squared. I want everyone to pause and make sure they wrote it down the correct way. Quantity, 2x squared. Alright, what is 12 squared? And then x squared we don't know. What's 2x squared?
4x squared.
4x squared. I have to, this is multiplication inside, so I have to square the 2 and the x. Or you can think of it as, it's 2x times 2x, which we should all be pros at now. We multiply 4x. Questions so far on what I've done? Alright, so now let's go ahead and solve. I'm just going to subtract my x squared. So I have 144 equals 3x squared. Now what? Good. Divide by 3. Got to get that x squared alone. Alright, can we divide 144 by 3?
Yes.
Yes, it's 48.
See, 3 goes into 14 how many times?
Four.
4 times, and I'm left with 2. So 3 goes into 24. 3 times. Alright, so x squared is 48. Now let's go ahead and square root both sides. Alright, I want you to go and simplify that on your own. See what you get. Did we get 4 root 3?
Yes.
Good. And again, we're going to take only the positive value. Alright, questions on that? Okay. Again, be very careful as you set up T. What is my hypotenuse for T?
10.
So this is my hypotenuse. So my leg x gets squared. Then I get the leg x plus 2. That whole thing gets squared. And 10 squared. Smart board come back. So again, everyone pause. Make sure you've written this down correctly. Notice it's the entire leg that gets squared. Alright, so I have x squared. What is x plus 2 squared?
X squared plus 4.
X squared.
X squared plus 4x. Huh?
Ooh, is it x squared plus 4x plus 4 or x squared plus 4?
But what do you
X
say?
squared plus
X
4.
squared plus 4.
No, it's 4.
X squared plus
What does squared mean?
Times itself.
Multiplied by itself. And what do I have to do here?
4.
FOIL! You cannot just square the first and square the second.
Oh my gosh.
What are the factors
Alright, so we end up getting x squared plus 4x plus 4 equals, what's 100? What's the word? 100. Alright, so now we see, you know what, just like that. We see that we have an x squared and an x. And Sam, what does that mean we have to do? We have to factor. So we have x squared plus 4x. What do we get for my constant?
Isn't it 2x?
Isn't it
2x?
Oh, sorry, thank you.
X.
2x squared plus 4x, what's my constant?
Plus
Two.
96.
Minus 96. And then we would have to go through and factor this. I would recommend you pull out that GC. Alright. Go ahead and do that, see what you get.
So if you start off those 2x squared plus 4x minus 9.
Start off with what?
I mean like 2x squared plus 4x minus 9.
Equals 0.
Could you like, never mind. Could you divide by 2 from the whole thing?
You can actually, yeah. Since all 3 pieces have 2, so what you're doing, Samir, is you're basically factoring out and dividing. That's perfectly fine. Yeah. Because this is an equation, that's what allows you to do. Because you have to do it to both sides, but what's 0 divided by 2? 0. Alright, what does x squared plus 2x minus 48 factor into? X minus 6 and x plus 8, are we good with that?
Yeah.
Questions on that?
Oh, yeah.
Okay, so now we set each factor. Can 2 ever equal 0?
No.
Nope, so that gives me nothing. There's not even a variable there. X minus 6 equals 0, x plus 8 equals 0. What are my possible answers?
X equals 6 and x equals -8.
X equals 6, x equals -8. Can I use one, both, or none?
X1.
Good, just one of them, x equals 6. Questions on that? Okay. And so now we come down to our final pieces for today. Yeah. It's a lot of little stuff. Alright, so our last two theorems are actually very similar to what we just did with our Pythagorean theorem. Our Pythagorean theorem says that if a triangle is a right triangle, I know that the square of the sides, a squared plus b squared, will be the exact same as the square of the hypotenuse. Add together, they give us c squared. Now, I can actually compare those same values and know whether my triangle is acute or obtuse. So this theorem here says if the square of the longest side of a triangle is greater than the sum of the squares of the other two sides, then the triangle is an obtuse triangle. What letter did we let represent the longest side of my right triangle?
C.
C. So let's go ahead in our picture here. Let C be the longest side once again. You don't have a picture? Okay, so just watch what I do up here. Alright, and then we let the legs just be A and B, right? So what this theorem says is that the square of the longest side, so C squared, is greater than, right, big mouth towards that, than the sum of the squares of the other two sides. And my other side is A and B. So go ahead and write this on your paper with that. If I take my small and my medium side and square them, add them together, compare that with my long side squared. If my long side squared, instead of being equal, is the bigger value, then it's an obtuse triangle. I know it's an obtuse triangle. I'm going to write obtuse next. Now this is a little different for acute triangles. Alright, so again, I'm going to let C represent my longest side, and A and B are my other sides. For an acute triangle, so again, right triangle, it's equal. Obtuse triangle, my C squared is bigger. For acute triangle, what do you think it has to be? Right, my C squared is less than. And again, this is for acute triangle. Now be very careful with this. I'm talking about my C squared is bigger and my C squared is smaller. Okay, so don't just look at the sign, because my inequality sign might lead you astray. For an obtuse triangle, C squared is bigger, so the mouth goes to the C squared. For an acute triangle, C squared is smaller, so the mouth goes to the, small end of the mouth goes to the C squared. So this presents with us three different situations. If it's equal, we know it's a right triangle. If C squared is bigger, obtuse. If C squared is smaller, acute. Yes?
So if you did one and then you did let's say you did the obtuse one, and if it didn't work, would you know that would be acute?
So you would basically, what you do is we just compare the values and then fill in the proper sign. So let's say we had 10 squared, and let's go with 2 squared, and I chose the wrong one. 11. Okay. What is 10 squared? 2 squared? And 11 squared? 104 be 104. 121. So what we're wondering is we want to know what fills in this box. Alright, are they equal?
No.
Nope. Which one's bigger? So I'm going to fill in that sign. Notice the C squared was bigger, so I know it's an obtuse one. So basically when we go through and do it, and I literally draw a box with a question mark. I don't know what sign is going to go there. Is it less than, greater than, or equal to? Alright, so guys, this is the way that our theorems are defined, but if you would rather memorize it like this, okay, let me pull this up. Okay, I know there's this problem here, but I'm just going to write it underneath it. if you would rather remember it this way, a squared plus b squared, a squared plus b squared, a squared plus b squared. Alright, if you remember it this way, c squared is equal is a right triangle. If my c squared is biggest, what is that going to be? Obtuse. And if c squared is smaller, what will that be? Acute. Some people like to memorize it this way. That's perfectly fine because then what you have is that it's greater than is how you would read the inequality as well. So you don't have to worry about whether the big mouth is toward it or away from it. So that would be perfectly fine there. But key thing, if your c squared is bigger, obtuse, c squared is smaller. Questions with that? Okay. So let's go ahead and knock these two out real quick. Again, we want to compare small and medium with my large. Alright, so 6 squared plus 7 squared, how does this compare to 8 squared? What is 6 squared?
36.
49.
64.
We're still trying to figure out that sign. What's 36 and 49?
85.
85. And what would be the proper sign?
Greater than.
Alright, so now again, stop and think. Is this going to be acute, obtuse? Acute, good. I see that 64 is the smaller, c squared is smaller, so this is acute. Questions with that? Okay, go ahead and try B, see what you get. That's a good time to know our squares. Alright, what is 7 squared?
49.
What's 14 squared?
196.
That is my favorite perfect square.
Why?
Because 13 squared is 169, 14 squared is 196. You just flip-flop the last two numbers.
So
But I like the even number.
Why don't you like? Oh, I like 13 more.
That's okay. And then what's 15 squared? 225. You are going to want to be familiar with your squares up to 15 squared. All right. So 49 and 196. What is that value?
It's just bigger.
Just
Bigger than
bigger.
25.
245.
245. And how does that compare here? So this is another acute. This is smaller. My c squared is smaller. Questions with that? Alright, now notice again your homework is textbook work. If you are struggling with certain concepts, the textbook has the information right before those problems, so look back at that. And next class we will have a quiz over this stuff and factoring and solving, so make sure you're prepared for that.
Is the homework factoring?
No, it's just practicing this. Yeah, homework is just practicing this. What's that? The textbook people. I got it from the textbook people. Yeah. Alright, you guys can go ahead and head out to lunch.
Could I take a picture?